OSPF supports point-to-point as well as broadcast network type. Apart from this, it also supports 5 different NBMA mode. I said it supports point-to-point, point-to-point, which is 2 routers connected using a serial cable. This is by default network type will be point-to-point. If you will be connecting through an Ethernet cable via switch or directly, this is considered as broadcast. I told you in the previous class.
Yeah.
Even if you connect through a switch, this is considered as broadcast. Whenever you have Ethernet, even if it is 2 router, without a switch in the middle, it is still a broadcast. So whenever the network type is broadcast, there will be a DR-BDR election. In point-to-point, there won't be DR-BDR election. I want to show you this. To understand this network type, we have taken these 2 routers. I'm going to quickly configure this using a notepad. Notepad really saves our time, so I'll say host name is R1, interface loopback is 0, IP address is 111.122.5.255.255.255, IP OSPF 1 area 0. So as usual, I am configuring OSPF, but the network type will not be same on serial and on Ethernet. That is what we are going to see. IP address is 10.12.0.125.255.255.0, IP OSPF 1 area 0. And now, when you put this on R1, let's go to the next router, finish the other routers, and then we'll go verify. Router 2 has got this as a router. Okay, this is the loopback. And on serial, I'm going to have .2. Correct? No, sir. Serial. Yeah. And then on Ethernet, 10.23.0.2. So there is no difference in the configuration. You can see the serial interface and Ethernet interface, the configurations remains the same. Yeah, there is no change. So let me put this on R2. And now the last router. And here we don't have serial, we got just one interface, Ethernet, so I'll remove this. Ethernet 00 has got .3 here. And this goes on router 3. All right, so what we are expecting is a reachability between R1's loopback to R3's loopback. Because we got OSPF everywhere, show IP OSPF neighbor. Okay, the neighbor is on the way, two-way. Let's wait. See, this is Ethernet, so there will be a DR-BDR election between these 2 routers.
Yeah, correct.
That's why it takes time. Let's go meanwhile to router 2 and check. Show IP OSPF neighbor. You can see here. Okay. You see on the Ethernet wire, you see a DR. Who is a DR? Router 3 is a DR because when you compare the router ID of router 2 and router 3, whose router ID is bigger? 3333 is bigger, isn't it? That's why this is DR. If you go and check in router 3 now, 2 to 2 is the BDR. Do we have DR other? No. There is no
Okay.
other here. See, there is a DR-BDR election, even though there is no need for DR-BDR election. DR-BDR, because it is Ethernet.
Because it's
DR-BDR
a
is
Ethernet.
actually needed when you have more than one neighbor. But I have only one neighbor for router 3.
Yeah.
Only one neighbor. And router 2, in this segment, in this LAN, how many neighbors for router 2? Only one. This is per link, per port. DR-BDR is per port, not for the entire router. So even though we have only one router, there is DR-BDR because it is Ethernet. Let me show you that. Because it is broadcast type. Network type is broadcast. See here, show IP, OSPF, interface, Ethernet 00. You see, the network type is broadcast. Got it, sir? What command I used? Show IP OSPF interface and then the interface name. The network type is broadcast. The priority is 1 and the timer is 10 and 40. And it says the router with this 3333 is the designated router and the backup designated router is the router with the 2222. This is, I said, no, it is per port. You see, per interface, per port. So the local device is the DR. Let us now go and check the same thing on R2. Here, what do we see? Here we see the network type as broadcast again because it is Ethernet. And it says the state is BDR. The local is BDR. Okay.
BDR.
Now let us go to
BDR.
router 1 now. Show IP OSPF OSPF neighbor. You can see there is no DR-BDR. And you see the priority is 0.
Yeah.
On the serial interface, by default, priority is 0 because there is no need for a DR-BDR election. Whereas on the R3, if you notice, the priority is 1. You can also type this command, show IP OSPF neighbor. You see the priority is 1. But on the point-to-point serial links, it is always 0, which means no DR-BDR election is necessary. Okay. What is next? I want to show you on the interface. Show IP OSPF. Interface serial 1/0. If you go up and see, you will again see the priority as 0. And look at this. The network type is point-to-point. We did not configure
Point to
this.
point. Network type.
We did not configure. Automatically it knows. Okay. But if you want this to be a point-to-point, you can do that. So that you can avoid that DR-BDR election. You understood, sir? So how do we do that? We need to go to the interface and say IP OSPF network type point-to-point. And now the neighborship will come back again by going down. And here also I'm going to say interface Ethernet 0/0 IP OSPF network type point-to-point. Point-to-point. After saying this, when you type show IP OSPF neighbor, look at this. The priority is automatically turned to 0. And there is no DR-BDR election.
Yes.
Let's check now. Show IP OSPF Ethernet OSPF interface Ethernet 00. Even though it is Ethernet, because we have configured as point-to-point, it has become point-to-point. So there is no DR-BDR election.
Yes.
All right. Now what is next? I also want to show you that 7 states of neighborship. We have not seen that, right? Let us see that.
Mm.
Now what I'm going to do is I'm going to
Yeah.
shut down the serial port on router 1 and router 2 so that we can see the election process. In fact,
Mm-hmm. But serial
no,
one and
that
serial
init state 2-way
2
state.
election won't be there, no?
Neighbor adjacency
Okay,
states,
neighbor.
the 7 states that you
Okay,
learned.
okay, neighbor
Do you
election.
remember
Okay.
the states? Can you tell me the states? Okay, starting from downstate, init state,
Init state.
two-way state,
X.
start state, exchange state,
Okay,
loading,
two-way state.
full.
X start exchange.
I repeat, init
Loading.
state.
Full.
Okay,
Yeah.
let me start. Correct, you are right. Down state,
Down.
init
Yes.
state, start state,
Yes. X start exchange. Mhm. Loading. Full.
we are going to see this thing as they form neighbor.
Mm-hmm.
On R2 also, I'll shut
Okay.
down the interface. Now I should not see any neighbor. Show IP OSPF neighbor. Gone. There is no
Mm-hmm.
neighbor. And I'm going to debug on R1 and R2. Debug IP OSPF events.
Mm-hmm.
Means even the hello packets it will show you. And also I want to
Mm-hmm.
show you ADJ. What is ADJ? Adjacency. See OSPF
Mm-hmm.
adjacency debugging. What is debugging? It will show even those things which are
Mm-hmm.
going at the background. By default, this background states we don't see.
Yes.
But if you want to see, you need to debug. So on R2 also, I'm saying
Yeah.
debug IP OSPF events.
Correct. Correct.
Debug IP OSPF adjacency. Done. Now what I'm going to do is I'm going to say no shutdown. I'll not hit enter now. Let me keep R1 also
Mm-hmm.
ready. Okay, shall I say no shutdown? Here, done. Now you're going to see, okay, interfaces come up. Okay, loading
Yeah.
to full. You see, it's already loading to full. Now let us go and undebug. Or you all means
Yeah.
what? Undebug all. Stop the debugs.
Mm-hmm.
Now let me go and show you the
And
states.
debug one. Yeah. Yes.
You see, this says two-way state. Okay, let me try to see init state.
Yeah.
Okay, we can see two-way state, and it says it's a point-to-point network, and unfortunately, it didn't capture the init state. So after two-way state, they will decide who is master and who is slave. And this guy says, we are slaves. It agrees. Why? Router 1 is saying we are slave. Why?
Yeah.
Because the router ID of router 1 is smaller.
We are.
Whereas the router 2 says we are not slave.
Smaller. Yes.
We are master. So it says this.
Your master.
And this is what called as extart state.
Mm-hmm.
Unfortunately, it is not showing that. Oh, here it is. Sorry. It's here. Extart state. In extart state only they decide who will be master. Only the one who is master will start sending the DBD.
Yes.
Yeah?
Extract.
The DBD. And then followed by the neighbor sending DBD. Receiving DBD from So when they have some queries, they send LSR, link state request, and they receive LSU. We call it as exchange state. After that, they don't have any queries. They are fully synchronized, so we call it as full state. And the querying state is what? Loading state.
Yes. Full state. So where is two-way? That
Here.
this one, that two-way, in our description we have not added that in the
Sorry.
lab picture, right? In the lab.
After init is two-way.
Yeah, I mean in the lab description, lab we kept a description of 6 days. Only 6 days are there. Like
that is solved. Right? So this is the sequence.
Yeah.
Now what is next?
Sure. Yeah, good.
Yeah. Correct.
So these states represent the adjacency state, right?
Yeah.
Okay. For example,
So
in case of R1, R2
between
is the
R2 and
adjacency.
R3,
So
again, it is
when this
separate process.
R2 is coming up, R1 is trying to make a
And
neighborship
in
with
here,
R2.
in the
So
extract state, you
this
will not see
state will
master
go
and
through,
slave.
right? For R2.
You will see TR, BDR.
Yes, correct.
It is Ethernet. Whereas here, it will be master, slave.
BDR, yeah.
One more thing is the master slave is not permanent.
Ethernet, R1 and R2 is
It's only for time being. Once it goes to exchange state, there is no more master slave. Whereas this DR BDR is permanent. You remember, unless you restart the OSPF, the DR router will be always DR. Even after the election, even after DR BDR election, it continues to be DR. Yeah. Yes, it will.
So if you restarted the box, then also it will come as a DR.
No, if the other one is having okay, if the other one is already running, if you are not starting all the router together, if you are starting all the router together, yes, what I said is yes. But if you just start only one router, the other router will take the DR posting. You're right. Yeah, 40 seconds. Correct.
Yeah. And what is the downtime? Was 40 seconds, right? Like to consider it is dead. Dead interval is 40 seconds. Okay. Maybe one, like a router is restarted, and if it is taking more than 40 seconds, then other router may be considering it as a dead. So it may remove the
I think you are
adjacency,
confused with few things. And
but what about the DR election thing? It will start.
Answer you. Listen, sir. You have a switch. You got a router. Router. And if you don't set priority, the network type is broadcast, and the priority is 1. When priority is 1, there is a tie-in priority. They don't know whom to select as DR. First, it will check the priority. Because there is a tie-in priority, they are going to compare the router ID. In the hello packets, the router ID is sent. So by comparing the router ID, this router 4 will know that I am the one who has got the bigger router ID. So router 4 will first say I am a BDR. And then afterwards it will say, because there is no one bigger, I'll be calling myself as DR. And now this guy will say, okay, then I am BDR, because there is no other one eligible for BDR, because I'm the next biggest. Now your story is, if this goes down, what will happen? You're right. This will become a DR. And these two will compare. And this will become a BDR. And now when this comes back, when R4 comes back, what will happen? When R4 comes back, because already there is DR and BDR, this will not be able to continue, join, this will not take the role of DR. This will go to other state. DR, other state. And now this is also DR other. So now if this DR goes down, then this will become the DR.
Other.
And this will become the BDR because this is the next biggest. And in case
Yes.
if the priority is 0 here, you can manually set the priority. Let me show you. If you want to set the priority, you can go to the interface Ethernet 0/0, IP OSPF priority 0. You can set priority like this. Okay. So if you set the priority 0, the router will not be considered for election. See, for example, this is DR. This is BDR, isn't it?
Yeah.
Now when R4 goes down, this becomes the DR. Now this will be skipped. It will not be considered. This will become BDR.
Correct.
Even though the router ID is bigger, it will not consider. First it will check the priority. If there is a tie in the priority, only then it will check the router ID. Is there a tie in priority here? No. So this will become a BDR even though the router ID is smaller.
Yeah.
Got it, sir.
Got it.
Now you ask me a question. Do you still have that
No.
old question that you were asking me before?
Yes.
Okay. Next.
No. Now
The other things that you are going to see in this chapter is not that important. It is a little bit outdated.
Yeah. Now I'm clear.
Like,
I will proceed to next.
We just saw this point-to-point and broadcast with nice lab. But this is an outdated one. You can go to a broadcast interface and you can make it as a point-to-point, isn't it? That part only you will learn in this 5 mode, because in this 5 mode, one of the mode is point-to-point. These are the 5 modes of NBMA.
Correct.
Non-broadcast multi-access. But once in a lifetime, it is okay to learn this. It is going to be a waste of time, I can say that. But still, if someone talks about this, we should have some knowledge on this. For that, we are going to learn.
Yes.
Okay. So the entire chapter is now going to be about this story of outdated one.
Yes.
Why I am calling it as outdated story?
Yes.
Because this NBMA is applicable only if you have frame relay or ATM or X.5. What is these things? These are all layer 2 technologies which we were having in 1990s. Very old and costly and slow technologies. Now we don't have these things don't have good scalability, so we don't have this thing. We have now MPLS, sd-wan, segment routing, etc. These things are outdated. So NBMA that you are going to study, the 5 modes, is only in this environment, which is old one. It's like for the ambassador car in India, you need to buy a special air condition. for ambassador car in India, you need to buy a special seat. Studying about the seat and air condition of ambassador car. Who wants? You don't have ambassador car today. One or two people here and there they have. Now, knowing about how to make an ambassador car, sophisticated car, ambassador car, what is the use now? In 1990s, it was useful. Today, learning about ambassador car is useless. Instead, you can take a tempo traveler and convert it to a what do they call it as? Camper van, or caravan. Caravan is for those celebrities. Camper van is like a house com van. Camper van. In Kerala, it is very famous. They all
Caravan.
they all make their
Caravan.
tempo traveler as camper van. Camper van.
Yeah.
My child always wants me to buy one camper van.
Yeah.
If God willing, I'll buy later.
Camping.
Yeah. So, 5 modes of NBMA is like studying about how to make ambassador better. And it is okay to learn only once in a lifetime. So, different behavior of OSPF in these environments like frame relay, ATM, and extra to 5.
So this modes means what?
We just finished learning this point to point. You remember I had a serial wire.
Behavior, okay.
Whenever you have serial wire, it is called as point to point. Why, the encapsulation type will be HDLC. Let me show you that. You see, on router 2, that is data link, high definition data link connection, something like that. I'll tell you exactly what it is. Now, show
what is HDLC, like full form?
So interface serial 1/0.
Okay.
Now, if you see here, the encapsulation type is HDLC. On serial encapsulation type is HDLC. On Cisco router, it is HDLC. On a non-Cisco router, it will be PPP, point-to-point protocol. In Cisco router, this is HDLC Cisco protocol. High level data link control. Okay. So the PowerPoint presentation was telling about this. Whenever you got a PPP or HDLC, OSPF will immediately take it as a point-to-point network. Now, if you take the serial link and configure sub-interface, what is sub-interface? Creating logical interface in that one physical interface. You can create multiple sub-interfaces from one physical. Then you need to have a frame relay or ATM on that point-to-point link. So, again, NBMA. No, I told you NBMA. You'll go to that mode. Anyway, those things are old technology. Don't focus. Now, as we saw, there was a master slave, and then that also got removed.
Okay.
There is no DR-BDR needed. When you have only 2 routers, why you need DR-BDR? So in serial, in a point-to-point OSPF network type, there is no DR-BDR. Next, OSPF auto detects its interface type. Yes or no? Did I configure anything like broadcast type, something like that? We did not. Automatically, it was showing network type as broadcast, isn't it?
Yes. Yeah.
So, And the only
No.
multicast address that was used is 224.0.0.5. Even this one we discussed in the yesterday's class.
Yes, yes.
Okay.
Yes.
And now, when you talk about the broadcast environment, we saw all these things. This is not new to us. We have seen this in previous class and also in this class. Whenever you got Ethernet link, it is going to take it as network type as broadcast. Don't worry about the token ring. It is old technology code. Now, there is going to be a DR-BDR election. All the neighbors will have full adjacency with the DR and BDR. Do you agree with this? Yeah. Every router will form full neighbor with DR and BDR only. With the others, they will have only two-way relationship, isn't it? Now, any communication to DRs, this will be used, isn't it? We saw these things.
Yeah.
Any communication from DR will be using this address. You agree? Okay.
Yes. Yes.
Now, I was telling you, first it will check the priority. I also showed you where to set the priority. Go under the interface and say IP OSPF priority command. And first it will not see the router ID. It will see only the priority. This has got the high, This has got the high priority. So this will become the DR. This is the next high priority. This becomes PDR. This will never participate in election. These two will participate, but because of the small priority, they both go to DR other state. Right? So only if the priority is same, the tiebreaker will be router ID. And the DR election is non-preemptive. That is what the doubt that you were asking. One DR was there, it went away, and when it comes back, and it became a DR. But can it become a DR? No. It cannot. Non-preemptive. So this is the command to set priority. This is the command to set priority. IPOSPF priority.
Correct.
Then you give it.
No, it won't. No.
0 means the router cannot be a DR or BDR. Okay, now NBMA has got 5 modes for which you need to have a frame relay or a extra to fire ATM. So what I'm going to do is I'm going to simulate frame relay for you in the next class. And then I'm going to take you through this 5 modes. Otherwise, you no need these modes actually. Okay, but we will learn how these modes will behave, so that you can also use these modes in Ethernet environment. You remember already we started using this in the Ethernet environment. Yes or no? We did it today. Yeah. So we can use any one of this mode if you like it. For that, we need to know what is the difference between these things, so that whichever you like, you can go and configure in the Ethernet environment. Yeah. Okay, then we'll stop here.